There's a strange blank space at the very beginning of your life. You know you were there. There are photos to prove it. You probably even know the stories your parents tell about what you did. But if you actually try to retrieve a first-hand memory from before you were 3 years old, you'll almost certainly hit a wall. In psychology, this is known as childhood amnesia. And it's one of the most universal, yet bizarre, things the human brain does. Think about how much happens in the first 3 years. You go from being completely helpless to walking, talking, and understanding complex social dynamics. It's the most intense period of learning you'll ever go through. But your brain apparently decided none of the actual footage was worth keeping. For decades, this was a massive puzzle. Why would evolution design a brain that meticulously records everything, only to wipe the hard drive a few years later? As it turns out, your early memories weren't just carelessly misplaced. They were actively dismantled by the very process of your brain growing up. To understand why, we have to look at a seahorse-shaped structure deep inside the temporal lobe, the hippocampus. If your brain is a computer, the hippocampus is the piece of hardware responsible for writing new files to the hard drive. The catch is, when you're born, this hardware is still under construction. It's only about 40% finished. So while a toddler is taking in a staggering amount of information about the world, the biological machinery required to encode long-term episodic memories just isn't fully operational yet. The experiences happen, but the tape isn't really recording. That explains why the memories don't stick. But recent neuroscience has revealed a second mechanism. And this one is much more aggressive. Throughout early childhood, your brain is engaged in rapid neurogenesis, literally birthing new neurons at an incredible rate. These new cells have to go somewhere. And many of them are integrated right into the hippocampus. Now, imagine a complex web of neurons holding a specific memory. When a massive influx of new neurons forces its way into that network, the existing connections get rewired. The physical structure of the memory is disrupted. It's a biological trade-off. Your brain has to choose between retaining old memories, or building the capacity to learn new things. It chooses capacity. It clears the old architecture to make way for a more advanced operating system. Interestingly, we see this exact same trade-off across the animal kingdom. Species with the fastest rates of early neurogenesis experience the most profound childhood memory loss. And because humans have an exceptionally long period of brain development compared to other mammals, we also have the longest, most extensive period of childhood amnesia. But hardware is only part of the story. There's also a software problem. Specifically, language. Before a certain age, you experience the world without a vocabulary. An afternoon at the park is just a rush of sunlight, the feeling of grass, and motion. There are no words attached to it. But as adults, our memory retrieval system is almost entirely language-based. We index our past using words. Because your earliest experiences were filed away without any linguistic tags, your adult brain doesn't have the right search terms to find them. It's like having a file on your computer, but since it has no title, the search bar can't pull it up. On top of the language barrier, there's an even deeper philosophical issue. To form an episodic memory, a memory of something happening to you, you first need a concept of you. Cognitive psychologists call this the cognitive self. And it doesn't really come online until you're around 2 or 3 years old. Before that point, experiences just sort of happen. There is no internal narrator. No protagonist to anchor the event. Without a concrete sense of self to tie the memory to, the experience simply drifts away. So, considering all of this, the underdeveloped hardware, the rewiring neurons, the lack of language, and the missing sense of self, it raises a pretty uncomfortable question about the few early memories you do think you have. Chances are, they aren't real. Memory researchers have consistently found that what we believe are our earliest recollections are often just reconstructions. You've seen a family video of a birthday party so many times that your brain eventually converted it into a first-person memory. Or you've heard a story about a vacation so often that you synthesized the imagery yourself. You aren't remembering the event. You're remembering the photograph of the event. Your brain essentially plagiarized external information and filed it under personal experience. For a long time, the scientific consensus was that our actual early memories were simply gone. Erased by neurogenesis and time. But recent experiments are challenging that assumption. Researchers working with rodents, which also experience infantile amnesia, used a technique called optogenetics to tag specific memory engrams. Later, when the animals had forgotten the experience, the researchers hit those specific neural pathways with a laser. Instantly, the forgotten memory was reactivated. The behavioral response returned. The memory hadn't been erased. The trace of it was still physically there, perfectly intact. The animals had just lost the ability to access it naturally. If human brains work similarly, it implies something staggering. Your first few years of life might not be gone. They might still be written into the physical structure of your brain, sitting in a dark room that you simply lost the key to. Every sensation, every early bond, every foundational experience that built your understanding of the world. Still there. Just inaccessible to your conscious mind. And perhaps that's exactly how it's supposed to work. We don't need to consciously remember learning how to balance, or how to process language, or who our primary caregivers were. We just need those early lessons to shape our instincts. The memories themselves fade into the background, becoming the foundation of our personality. You can't remember those years, because they didn't just happen to you. They became you. The blank space at the beginning of your life isn't an empty hard drive. It's the operating system running quietly beneath everything you do. If you found this interesting, hit subscribe. We explore the strange mechanics of the human brain every week.